For this example, we have the following polynomial f, which is given up here, and we want to try and identify some possible values of x that will make the function equal to 0. And we're going to do this by looking at factors of the leading coefficient and the constant term. So the first question in part A is, well, how many possible zeros can f have? And since f is a degree 4 polynomial, this tells us that at most we can have 4 zeros. So to answer part A, f can have at most 4 zeros. Doesn't mean it has to have 4 zeros, so don't be surprised if we find that f only has 1 or 2 or maybe doesn't have any zeros at all. But we shouldn't find more than 4 zeros. So it could have 0, 1, 2, 3, or 4 zeros. In order to find a list of candidates that could possibly be 0, or at least the rational numbers that could be 0, let's recall the following fact, that a rational number can be 0 of this function only if is of the form plus or minus p over q, where p is an integer factor of the constant term, a0, and q is an integer factor of the leading coefficient an. So in this case, we note the following, that a sub 0, the constant term, is 3. And a sub n, the leading coefficient, is 2. So the values, the factors of the constant term, a0 equals 3, has integer factors plus or minus 1 and plus or minus 3, and that's it. The constant term, the leading coefficient, an, which is 2, has factors plus or minus 1 and plus or minus 2. So the only possible candidates would be things that look like plus or minus 1 over 1, which is plus or minus 1, plus or minus 3 over 1, which is plus or minus 3, plus or minus 1 over 2, which is plus or minus 1/2, and plus or minus 3 over 2. And those are the only possibilities. So here I've taken different combinations of factors of the constant term, 1 or 3, and put them over different combinations of factors of the leading coefficient, which is 1 or 2. So that gave us the 1 over 1, 3 over 1, 1 over 2, 3 over 2. And to see which of these work, none of them, it's possible that none of them work, let's go ahead and take a look at the graph. So I've got the graph over here, and let's zoom this in a bit. And so if, for example, we use technology to graph this, say using Desmos, then we could scroll along the graph. And what we would see is that over here, we see that minus 1 is indeed a 0. So this gives us x equals -1, that works. And over here, we can also see that x equals 1/2 also works. The others don't. So here we are at ±3, and it's important here that my window I did include x values for the largest possible candidate. And so this one doesn't work. Neither of these work because here we can see the graph doesn't cross at -3 or 3. And we can also see that ±3/2 doesn't work since 3/2 is 1.5. And it doesn't cross here and it doesn't cross over here. So these two also don't work. And the other two, they occur somewhere at an irrational number, at a number which is not rational. So there are two other zeros, namely this one over here and this one over here, and we still need to find out what those values, what those zeros would be.